This lecture will explain the rules called DeMorgan's laws, or just DeMorgan's for short, which we abbreviate D, capital D, small e, and then a capital M. So the way DeMorgan's works is if you have a negated conjunction, a negated conjunction, then what you can do is you can push those negations in, and when you do that, they attach to each of the conjuncts, and then the and switches to an or. So you go from the statement, it's false that P and Q, to the statement, not P or not Q. Likewise, you can go from the statement, it's false that P or Q, and you can push that negation in and get not P and not Q. And of course, you can go the other direction too. So if you have not P and not Q, you can, I think of it as like pulling the negation out. And then when you do that, the and switches to or. Or if you have not P or not Q, and you pull the negation out, then the or switches to and. And these are my favorite rules of all time. In particular, I use the versions with the negations on the outside the most. So I move from the negated formula to ones where the negations are attached to the formulas inside. Because when you have a formula that has a negation outside of the formula, there's not really a whole lot you can do with it. So it's always better to push those negations in. So as soon as I see a formula that has a negation on the outside of either a conjunction or a disjunction, I just DeMorganize that. I just push those negations in. In particular, I really like this version because when you DeMorgan's the negation of a disjunction, you get a conjunction, which is all kinds of useful because then you can just take it apart and get the pieces. You can't quite so easily take apart the disjunction, but it's still more useful than the negated conjunction. So this is a really useful rule. There's a similar kind of rule for the conditional that I'll discuss in a later tutorial, the rule of negated conditional, that lets you push negations in on conditionals. And we're also going to, later, when we talk about biconditional expansion, I'll show you how you can use that to push negations in for a biconditional statement. It's a little more complicated, but it works. And in all cases, it's just better not to have that negation on the outside.